Hello, this is Mr. Stewart bringing you 3.5 homework quiz. I'm going to start changing the title. It's not going to say homework anymore. We're going to start calling these practice quizzes. Sometimes we do them at home, sometimes we do them at school. Either way, it needs to get done. So anyway, we're going to start with the quiz. Now, 3.5 quiz is a combination of 3.4 and 3.3 all together. And so you need to understand that the 3.5 quiz is going to both include additive inverse and multiplicative inverse. So we would call these, some people call them two-step equations. I think I'm not in love with that term. I think I would mostly just call them multi-step equations. Equations that would require you to use multiple inverse operations in order to solve. Let me show you an example here. So question number 1 says, solve the equation by placing the steps in the correct order. Drag each step to the place it belongs. Here's the equation. Now, as you're working with the equations, and this is how it works. So you would literally drag, you'd click one of these and drag it up or down, depending on where you thought it belonged, the step belongs. So really, I mean, you can break this up into many steps. We kind of broke this up into 4 steps. But let me just make up an equation for you, and I'll do this off to the side, and then we're going to talk about how this works. So I'm just going to do 8 plus, let's do, I don't know, I'm just going to make it up, so it may not come out really nice. Let's say plus 2n is equal to negative 10. We'll do that, okay? Now when you're working with multiple operations, you got to notice something, right? Here's the n, and n is being both multiplied by 2 and is also being added by 8. And so really there are 2 terms that you need to get rid of, you need to cancel out here. You want to get 8 out of here, and you also want to get the positive 2 away from the n. If you can do both of these things, then you'll be fine. Now here's how it works. Whenever you're working with multiple inverse operations, it's always a good idea. I won't say that it's necessary, but it's always a really good practice to get rid of the additive inverse stuff first. So this would be kind of step 1. I want to get rid of this positive 8. Well, how do I get rid of a positive 8? I have to do the opposite of a positive 8, which is a negative 8. I'm going to subtract 8 from both sides, or I'm going to add a negative 8 to both sides. Remember, I've got 2 sides of this equation. The whole reason I'm doing this is to cancel out this positive 8. It's one step closer to isolating the variable. So that goes to 0. This is a 0 pair. And 2n is still left alone. And that's going to be equal to or balanced with my new set of numbers over here, negative 10 and a negative 8, which is negative 18. And that's fine. That works just fine. Okay, now the step that comes next would be, now I want to get rid of this 2. 2 is being multiplied by n, so here's my next inverse operation. The inverse operation of multiplication is division, so now notice I'm doing a different group of inverses, okay? I'm actually dividing both sides. I'm doing the inverse operation of multiplication. So this time, the multiplicative inverse cancels out to go to 1, not to 0, and that's the difference between multiplicative and additive inverses. So 2 divided by 2 goes to 1, which means that 1n is isolated. That means n's all by itself. And so n is equal to whatever, I have to do the same thing to decide whatever negative 18 divided by 2 is, which I get to be a negative 9. And so now you could take this and you could substitute this answer back into the original n just to see. And negative 9 times 2 would be negative 18, and negative 18 plus 8 does equal negative 10, so that checks out. Now I want to do something here. I'm going to go all the way back, and I want to show you what happens when I do the other inverse operation instead. Okay, so I told you at the very beginning that it was a good idea to do all of the additive inverse stuff first. That is a great idea. It always keeps things a lot cleaner. But what if you don't? What if you started with the multiplicative inverse first? What if you started here? Well, let me show you what happens. It works. It still works, but you need to understand how it works. When I am trying to cancel out this multiply by 2 right here, when I need to cancel this out, I'm going to do the inverse operation of multiplication, which is division. But if I start with this and I've still got this positive 8 out here, what I actually need to do is divide this entire quantity by 2. You need to understand that whatever I do to one side of the equation, it happens to the entire expression on that equation. So when I started with this and I took away 8 from both sides, I literally took 8 away from this entire expression. The only result was that it canceled out this positive 8. But now what I'm doing here, I'm sorry, I need to divide the entire quantity by 2. But now, if I divide both sides by 2, I can't just divide this by 2. I have to do the entire thing by 2. And that works, okay? Remember what we got for the answer. I think we got n is equal to -9. Well, now I can say, okay, I can split this up into 2 different groups. 8 divided by 2, right? And also 2n divided by 2. And we now know what happens. Oh, and that, I'm sorry, I need to do this side. I need to do the same thing to this side. So that goes -10 divided by 2 is -5. And that is equal to -5. Now we can reduce this, simplify it. 8 divided by 2 is actually 4. 2 divided by 2 goes to 1. That's canceled out and left with n. And I'm one step closer to isolating the variable. And there you go. Now all I have to do is do the inverse operation of positive 4, which is -4. If I minus 4 from both sides, that goes to 0. There's my additive inverse, or 0 pair. N is equal to a -9. Right. So I got the same answer, but that's only if I, from here, I divided both sides by a 2. So the only reason I'm showing you this is because when you're looking at this answer here, when you're ordering these, I still want you to start with the additive inverse. This is how I'm going to teach it, and this is how I expect most of you to approach this, because starting with the multiplicative inverse is going to be a lot more work down the road. And so do that, and that should be fine. Okay, now it just comes time to start solving for the unknown variable, making sure that you write the numerical answer in the blank. And so I'm just going to make one up. Okay, so I've just made up an equation that you can sort of follow the steps and just kind of help you if you're struggling with equations and solving and finding the solution to equations. You can just think of this into groups or multiple steps. You want to start with the additive inverse first. Here's a positive 8. I can cancel that out before I ever try to start canceling out the 6 times v. So I'm going to cancel this out by subtracting both sides of the equation by 8. Whatever I do to one, I have to do to the other. And then this is a 0 pair, and that goes to 0. That cancels out, and I just do the operation here. 38 subtract 8 is 30. So now 30 is balanced with 6v. Now I just want to split this into 6 equal parts to get rid of this 6. Okay, so I'm going to divide both sides by 6, and 6 divided by 6 goes to 1. That cancels out and leaves v by itself, and v is equal to, I got 30 divided by 6, which is 5. Right? I could substitute that back in, and 6 times 5 is 30, plus 8 is 38, and that checks out. Now that's not what your equation is, but hopefully seeing me solve this kind of helps just a little bit. Whoops, clicked on the wrong one. Okay, moving on to question number 3. I like this question because this is really kind of getting into the whole, this really is multi-step equations, right? There's a few things you can look at here, and I'm going to make a question up so that it works. Okay, so I've just made my own equation up that is similar to the one you see over here. It's not the same, but similar, so that you can kind of see the steps. 2 different ways that we can actually approach this. You may choose to distribute first the 4, which I will show you how to do first. Okay, don't forget 3.2 is all about distribution. If you're stuck on that, you might want to go back to the 3.2 quiz and discussion and maybe watch those video tutorials again. But all you're doing is multiplying, this is distribution, so it's multiplication, 4 into this entire quantity. So 4 times b is 4b, and 4 times 6, I'm sorry, a negative 6 is a negative 24. And so now this is becoming a two inverse operation equation. And so I'm going to do the positive 24 first, and that equals 6 plus 10 is carry it to 40, so that equals 40, and 4b is equal to 40. Divide both sides by 4, because that's the inverse operation that's happening here. That goes to 1, and b is equal to 40 divided by 4, which is 10. You could substitute that back in. Okay, so that's one way I approach it. I can show you another way. So if you wanted to observe that, you can go back and just kind of hit pause. I want to show you one thing here that you can do. Since 4 is being multiplied by this entire quantity, I could inverse that operation out. Now watch what happens. I could actually divide this entire quantity by 4. And that means I would have to do the same thing to this side. And whenever I take a group of numbers that's being multiplied together and then divide by one of those numbers, that's just going to cancel out and go to 1. So 4 is going to easily cancel out the 4 in the denominator, and b minus 6 is what's left over. Now that equals, let's see, 16 subtract 4 is 12, and so there you go. And now I just have to add 6 to both sides. Add 6 to both sides. Aha, I did something wrong. Okay, apologize. So 16 divided by 4 is 4. There you go. 16 divided by 4 is 4. Got to keep my operations straight. So it can happen to anybody. I have seen students do this before where they were dividing both sides by 4 and then ended up adding these together or subtracting or something. So anyway, I must be hanging out with 7th graders. Now I can add 6 to both sides, and now b is alone, and that equals 10. So there we go. So that is another way to approach this. I prefer the first way, to be honest, even though it seems like it's more work to distribute. It helps me keep track of things, but you can do either way. Okay. Question number 4, similar to question number 3. The only difference, I suppose, is that the variable x is going to be on the right-hand side, but that just doesn't really matter because all we have to do is just find the solution that makes this equation true. Okay, so I've made up my own equation that's similar in style to what you see down there, so it may just help you see me approach this and go, yeah, that's how you're supposed to do it. Again, you can do it 2 different ways. I could either divide both sides first by 10, or I can distribute first. I'm going to today choose to distribute first. So I'm going to distribute the 10 into the 3, which becomes, 30. And I can distribute the 10 into the x, which becomes 10x, and that is still equal to 100. Now I'm going to work on inverse operations, and I'm going to start with additive inverse stuff first. So I'm going to subtract 30 from both sides. And so that's 30 subtract 10, 100 subtract 30, which should be equal to 70, and that's equal to 10x. So that just comes down. Now I just think to myself, okay, this is multiplication. The inverse of multiplication is division. So I divide both sides by 10. That goes to 1, and I'm left with x is now isolated, and 10 goes into 70 7 times, so x should be equal to 7. I can substitute that back in to double check, and sure enough, 3 plus 7 on the inside is 10. 10 times 10 is 100, and I'm good. Do the same thing over here. When you think you've got the answer for x, I would advise you to substitute that back in, combine the terms inside the parentheses, multiply it by 7, and see if it really equals 84. So, in other words, the answer you put here should not be a guess. There is no way that you should be entering this in and not knowing for sure if this is the correct answer. Last question. Here we go. Okay, in this case, again, this is what we would call a multi-step equation. Taking a look at this doesn't throw me off too bad. This is now going to draw you back to the 3.1. 3.1 is all about combining terms that are alike. So you've got yourself a term here, and, you know what, hang on. You've got yourself a term here and a term here that can be combined because they are alike, and that'll simplify things into just a single expression where you've got a negative 5 and 3/10 b, and then a negative 1 and 5/10. That would be more. So you're going to simplify first. Simplify. So simplify that first, and that should be better for you. Okay, so I've just made up my own example that's similar again to it, but not exactly the same. So you can't just scroll through the videos and get the answers, but maybe they will be of help to you to see me talk and walk through these. So again, I've got some terms here that can be simplified, that can be combined. So a negative 1 and 5/10 can be combined with a positive 1, and that would equal a negative 5/10. So what I'm doing is I'm just simplifying this expression on the left-hand side down before I even attempt to find the solution to this equation. That's going to be helpful there, I think, in the future, because if you don't simplify this, you're just going to have to do multiple inverse operations, which isn't fun. So, well, at least it's not fun for most people. I rather enjoy it. All right, we're going to keep going with this. And so, let's see. First thing is to cancel out the multiplicative inverse. I'm sorry, the additive inverse. So I'm going to actually add 5/10 to both sides. I can do that even though they're decimals. Gosh, they're just numbers still. And so I'm just going to combine those. That's going to cancel out. It's my additive inverse. So I'm left with a negative 6 and 3/10 b is equal to whatever negative 13 and 5/10 is equal to. And that happens to be equal to a negative 12 and 9/10. So if I take negative 12 and 9/10 and subtract negative 0.5 from it, I should land at negative 13 and 4/10. So that's right. That looks good. And then all I do is cancel out this multiplication. This is multiplication right here to this b. So the thing that is inverse of multiplication is division. So if I divide both sides by a 3 and 6 and 3/10, divide both sides by a 6 and 3/10, this is what I'm going to get. So this, let's see, this cancels out and goes to 1. So b is left alone, and b is equal to, let's see, I just put this in my calculator and I get something crazy. It's going to be a positive because a negative divided by negative is a positive. So that's a positive 2, and I'll just round to the nearest 1/100th, 47 100. So maybe even 48 100, somewhere around there. And this looks like it's going to be a repeating decimal. So I'm going to just stop there and call that my solution for B. Of course, that's not your solution. I believe your solution should be a terminating decimal. So that might be a good clue for you if you get something crazy like mine. I just made this one up without really thinking about what the answer could or should be, so I just ended up getting something a little bit off. But I could be able to substitute that back in and double check to make sure that this actually works. So hopefully these quizzes, or watching me go through these quizzes, is helpful for you. Maybe take it a second time, and good luck with everything.